Welcome friends. Today in this tutorial I'm going to discuss about the Faraday's law of electrolysis. In this I'm going to discuss the statement, the experimental verification of Faraday law electrolysis. There are two laws, first law and second law, and just come on to discussion over it. Number one, that is first law of electrolysis. First law of electrolysis states that the amount of substance liberated or deposited in electrolysis is directly proportional to the charge passing through the electrolyte. It simply states that the amount that is deposited on electrode or during the process of electrolysis, that is directly proportional to the charge passing through the electrolyte. The amount of charge which is passed through electrolyte is directly proportional to the amount deposited. That is simply a first law, and symbolically we can write M denotes for mass deposited on electrolyte and Q the charge, and symbolically it can be written as M is directly proportional to Q. To remove the proportionality sign we use the constant, that is Z, where Z is a constant, M equals to ZQ, where Z is constant and is known as electrochemical equivalent, whose short form is ECE. As we know, I is equals to Q by T, current is equals to charge per unit time, and from that only charge equals to product of I and T, or I times T. Therefore M equals to ZIT. And this was the first law statement, and now we are going to verify experimentally the first law. Experimental verification. Now we are going to discuss the experimental verification of Faraday first law of electrolysis. So now the experimental verification of first law of electrolysis. For experimental verification we have certain apparatus, that is voltmeter, electrolyte, cathode, anode, or this is rheostat. Rheostat is used for changing the resistance, due to which current is changed. Desired amount of current can be passed through this electrolyte. And now for the experimental verification, we should arrange the apparatus like this. It means there should be a voltmeter where one anode and another is cathode dipped in electrolyte. This is electrolyte, which is CuSO4. This is rheostat. This is the emitter to measure the current, what amount of current we are passing. This is the key to on or off the circuit. To break circuit it is used, and this is the PD or EMF, or we can say the battery, which provides the EMF or the charge to this circuit. Now for experimental verification, the apparatus are arranged as shown in the figure. We have discussed about that. Now when steady current I passes through the electrolyte, that is through the electrolyte CuSO4, for certain time t, the electrolyte CuSO4 solution decomposes into Cu++ and SO4 minus. When electricity is passed through the electrolyte, it decomposes. This is known as electrolysis, and this the solution or the electrolyte CuSO4 solution decomposes into Cu++ ion and SO4 minus ion. Thereafter, suppose M1 be the amount of substance deposited on cathode in time t due to the passage of current I1, then we have from the first law M1 is equals to ZI1T from first law. This is I have taken from the first law, and again hence the experiment is repeated. The same step is repeated. Just M2 mass is deposited on cathode due to passage of current I2. Just we have changes the current. Here was I1 and there is I2. Just current, the amount of current passing is changed. almost the time is same, and when the current is changed, the amount of current is changed, mass is changed. That's why there is M2 mass that is deposited on cathode. And then we have from the same the first law, M2 is equals to Z I to T. As T is same, I1 and I2 is different, Z is the constant which will be the same, and the mass deposit is different. That's why here is M1 and here is M2. By dividing the equation 1 by 2, we get M1 upon M2 is equals to Z I1T by Z I2T. From here we can see that Z both are same, that is same constant, it's cancel out, and I1T means IT is equals to Q. That's why I have replaced IT by Q. There is I1T, that's for Q1, and I2T, that's why here is Q2. And from this relation, we see that M1 is directly proportional to Q and M2 is directly proportional to Q2. M1 is directly proportional to Q1 and M2 is directly proportional to Q2. That's why M is directly proportional to Q. And we have to prove this, and we have verified it. It's okay. Thanks. That's all from my side. And this was experimental verification and the statement of Faraday first law of electrolysis. Thank you.